Hello everyone, today I wanted to talk about an HTA I have been building in my spare time. It's an HTA that uses machine learning neural networks to predict the source skeleton matches onto your target skeleton, and then I'm using Houdini tools to rebuild that source skeleton to match the target skeleton. The problem I'm trying to solve here is it's not much of a problem, but it can be a problem when it's obviously repetitively done, and it can be very individually character based. I'm trying to generalize the retargeting using machine learning to demonstrate how AI can help us basically retarget clips without the artist having to sit there and map joints character to character. And this uses a different workflow where I'm completely rebuilding the skeleton rather than using the map skeleton and full body IK to solve. So here is the tool. Here is our input geometry manning coat. It's a free tool. You guys can find it online. Shout out to the person who has built this. I'm just here removing the mesh, anything that I don't need. So it's just skeleton. I want to showcase the skeleton. Obviously, it's important. I tried to pick two skeletons that had very different naming conventions to showcase how strong this can be. So neck, head, right arm, right forearm. As you see, the skeleton is, it's pretty simple, I would say. So I think it's 52 points. Yeah, it's 52 points. And here is our target skeleton. It has 88 points, 88 joints. It has twists. It has very different finger names. It has very different leg names. Even the spine is different. I would say spine is probably a bit more similar than the rest of the stuff here, but it's pretty different compared to our target skeleton. So we're going to input here the target skeleton rest, the target skeleton animation, the targets. We're going to take the source skeleton rest, source skeleton animation, and here all you need to do is set a minimum threshold where the machine learning model will go ahead and it will say, okay, if this is the minimum threshold, I will put out all of the bone matches up to that, and below that I don't. Obviously, the lower you go, the more chances you might get the mapping wrong. But in my case, because the skeletons were very different, I wanted to go low so that I could find the most matches. In our case, it found 53 out of 62 joints in our target. I think 65. I think that's pretty good. If you look at the rest, there's only 52 joints. So I think we're in good shape here. I don't think I need to add anything, to be completely honest. I think I want to just showcase what it can do without having to do everything. But in production, you would probably sit here and you would match all of the ones that says none. Not all, because obviously we don't have eye joints and we don't have jaw. But all the ones that could potentially be those joints, you would match. You would look at the fingers and see how many joints there are, etc. But in our case, I'm just going to showcase the tool, see what it can do and how powerful it can be, just by pressing a few buttons. So we have here 35 on match, as we just looked. You can match them yourself and it will still give you something. Um, we have, if we go down a bit, you can see the finger matches. When I was building this, I was training the machine learning model. Fingers were absolute nightmare because obviously in most rigs they are in different positions, they are in different rotations. But once I, kind of locked in on the fingers, I think I'm getting pretty good results, even though the naming conventions are very, very different. And I'm pretty sure the placements are always different as well. You can see the left thumb 3 is not very sure, and like any 3, it's not very sure about. As you see, they have the lowest confidence score. I think this is due to the fact that there is an end joint, and one of them has 4 finger joints, the other one has 3 finger joints. So obviously the machine learning model is like, oh, which one is the end one? Is it the fourth end one, or is it the 3? But I decided 3 was the one. So let me show you guys what the output is. So this is the skeleton output. As you see, the first frame will always be the rest pose, and then once I play this, I'm hoping we just get the animation retargeted onto our skeleton. So this is the retarget animation that we're getting. This will be the motion clip, which I will show how to put into an agent in a second. So here is what we're getting. So here is our retargeted animation. So I think it looks pretty good. I would say, for a few button clicks, I think it works quite well. So far, this neural network is only built on human, but once I have all of this down and it generalizes well and it works well, I would like to, go ahead and I would like to make this so that quadruples and other type of skeletons can also be ingested, and we can use machine learning to solve retargeting. Because in our case, we have old clips, we want to use those clips in crowds from our archive. We don't want those to go to waste. We want to use those to add more randomization. Um, let's continue for now. So this is a motion clip of that clip that we just got. So if you had an agent, you can basically just take the mocap and you can put it into your, as you see, this is the mocap. You can put it into your agent clip. Let's say we have an agent here, Manning coat. So we can just put him in an agent clip, and if you set up your locomotion, it says Clara walk because I was using another model called Clara. We could just say walk. We can just change this to walk, and the locomotion should work as well, and this man should go forever. So yeah, I believe this works really well. For those of you who are interested, I'm probably going to continue, and I'm going to showcase some of the stuff that I have done to be able to build something like this. So if you are interested in how I built this, please stick around, and I'm going to go ahead and I'm going to show some of the code from Python that I'm using, and I'm going to also show inside the HDA how I'm rebuilding the skeleton. But those of you who just wanted to see the tool, this is the tool. It's pretty much a plug in and play. In production, as I said, I think you would probably need to go into here and you will need to change some of this because not change but match them so that you can get always a smoother look. But yeah, this is the tool. I hope you like it, and for those of you who are interested, I will continue to showcase. Thank you. So I've just watched the video and I realized it's 7 minutes long, so I'm going to try to make this as quick as I can. So I'm first exporting an information. This is an Excel file from Houdini. I'm basically looking at the geometry spreadsheet and I'm exporting like the position X, position Y, the depth, the child indices, the parent ID X, uh, vector parent X. So it finds all of the parent stuff. It finds the scale, orientation, rotation, translate, local transform. There's a lot of, so as much as information as I can get, I'm exporting all of the local transform. Obviously it's a 4x4, so I'm getting about 16 local transform features as well to feed in, and then I'm getting a local transform clean, which is another feature that I'm giving into it. And once I export out of Houdini, then I go into Train Matcher, which this is the old one that uses it. So I'm going in here and I'm building a lot more. I was sort of hoping that I had more time because I've used LLMs to actually comment my code for the first time so that I could explain what it does. But I'm just going to go ahead and talk about some of this. I'm basically tokenizing each of the joints. I'm removing all of the separators if they do have any separators, and I'm completing name similarity between those tokens, and I'm loading the rig. I'm taking all of the parent and position and all that sort of stuff, and then I'm returning it as a input that will go into the machine learning model, and then I'm computing the depth, which is another one. I'm computing the median scale. I'm normalizing the vectors. I'm extracting the joint features. I want to show where I'm building the machine learning models. So uh, here is the machine learning model. Here it is. So I'm using only 20 epochs. I found out that if I'm using any more, the conversion becomes quite low. So I'm only going up by 0.05% an epoch, and I don't think it's necessary in this case. Obviously, if I had more, then I might have to increase it. Here is the machine learning model that I'm using. It's a TensorFlow neural network. It uses 4 layers with one output layer, which is the confidence score. It's a pretty standard model. I'm using 2% dropout. Dropout means that it drops out some of the values so that it gives the machine learning model a bit more randomization. To explain, I'm using binary cross entropy. I'm using the Atom optimizer, and I'm using accuracy score to train. This is where I'm training, and then I basically get back all the stuff that I need. And basically, this is the main. It just sort of tells you what's happening. If I am to run this, it will take a bit of time. So as I'm already 7 minutes there, and plus this, I don't want to really run this, but it gives me all the stuff, and it saves the model out, which I take from here, and then I put it into my hit file. And it does a testing name convention, and yeah, this is the code to build the machine learning model using all of those features. And I will catch you guys back in Houdini very quickly. So back in Houdini, we can continue from where we pretty much left off. I am using this Python script here that basically takes in that machine learning model and it will run it. Do you see I'm importing TensorFlow here? It basically just a greedy match, so it will look left, right if there is one, and it will use the confidence score 0 to 1 as I said, and try to match the joints based on all of the information that I've given the model. It's a pretty long code. I don't particularly. I would love to sit and explain, but I don't think it's actually necessary, and it would take me a long time to explain all of this. But basically, I'm just taking in the nodes. I'm basically taking the geometries between them, and I'm basically doing all of the extraction that we did originally to train the model on the Houdini nodes here, and then I will run the model here. It says the model, load the model, and then you extract the features, you extract the source, and then you basically compute the scores using those things. And as you guys saw in the print, there's a Hungarian match here. It does a Hungarian greedy match. It works pretty well, I believe. And then I'm basically outputting a skeleton that has some features, this is the node view. I'm outputting a skeleton right here that has everything that we need. So there you go. It's the rest, so I'll use the rest. It's easier to match when it's rest. I don't really want to use animation. I just sort of rebuild it onto the animation. You can see the match name. So you can see the name of the joint and you can see what it matched to. Some of them I can open up a bit more. There you go. So these are the matches. You can even see the scores. So you can see how well they matched. So we can look at like the top ones. The machine learning model is sure these are one another. But if we are to go down a bit more, you can see these are the matches basically. And then there's a PT num obviously as everything else. I want to showcase the Houdini now. Basically what I'm doing is essentially I am setting a keep. I'm just saying if there is match ones then keep, the rest you don't need to keep. Find the missing joints, it finds the missing ones so that I can rebuild them on top. So I'm basically removing all the ones that I don't actually have. So this will have 53 points, but I'm missing some joints, right? Because there were 65 points in our animation. So I'm just making them the same name now. So essentially we have joints that are exactly the same as our thing, uh, target. And then I'm adding the joints, the missing ones back, and I'm setting all of their name, scale, and attribute, as you see here. And then so I'm getting rid of all the bones, and I'm rebuilding the entire skeleton to match our joint, and I'm doing the exact same thing, but this time I'm actually transferring the attribute from our rest using the keep attribute, so I can delete all the joints that we don't want, and I can find the joints that are missing again, which is 12, and then I can set the name, I can take the joint, and I can rebuild the skeleton, and this will do the rotation for us. As you see, I rebuilt the skeleton. And then I remove all the eyes and jaws. I don't have any models that have eyes and jaws. They were causing a bit of a problem, so I'm just removing them. And then all of this is just fixes. I believe they work well, but I'm using skeleton blend. I'm also using orient joints, and then I basically at the end fix the spine. There was an issue with the coat man spine. Clara into coat man retarget. There was also an issue, but yeah, we get an animal here. Um, so yeah, thank you for watching. If you have any questions, if you want to find out more about this process, please let me know. I will try my best to answer any of your questions. Um, you know, yeah, I believe it works quite nicely. Man in coat, legend. Um, also another thing you can do is you can set the clip name. You can say man in coat walk, and then you can pack this, and then you want to bring this as packed. Should come up as a yeah. You see, it says man in coat walk. This should work as intended. Uh, I mean, if you are to export this, basically what I'm saying is it does have the naming convention here. But if you had loads and you packed loads, and then you can put it in here, and then you can say packed primitives, and it should work. But yeah, you can set the clip name. That's just what it does. It doesn't do anything else apart from that. You can also auto fix the missing joints. It shouldn't change much of this, but it basically adds all the joints that I've just shown in the process, and then it rebuilds the skeleton for you. So yeah, thank you for watching. As I said, if you have any questions, please don't hesitate to reach out, and I'll see you guys on the next tool.